Hello students. Today we're going to work on looking at problems numerically, algebraically, and graphically to try to come up with solutions or answers about how these problems are represented to us. In example 1, there's data showing minimum hourly wage from the years 1955 to 2005. What I want you to do is I want you to look at the data and I want you to notice there are two columns, and I'd like you to analyze what you think about the minimum hourly wage and also what the purchasing power for those years would have been. Pause the video, write down what you think, what the data table makes you think of, and then we'll come back and answer a few questions. Okay, so hopefully you've had a moment to think about the data and look it over. And there are a couple things that we're going to definitely discuss in class. But I just want to make you aware that if you look at the hourly minimum wage back in 1955, in dollars based on that day, the hourly minimum wage was only 75 cents an hour. But that gave you, as in 1996, a purchasing power as if you had a $4.39 cent per hour minimum wage. And as you look at the hourly minimum wage, you can see that it's going up every year up until 2005. That's what the data shows us. But notice the purchasing power fluctuates, and this is all based on inflation. So just because you have a higher minimum wage doesn't mean you have more purchasing power. These are the types of things that sometimes when you look at data, you have to look twice at to see what you're really getting. In answering a few questions about the data, can you answer, and pause the video when you answer this, but can you try to answer in what year the workers had the worst purchasing power, where they had the most purchasing power, and where they had the greatest increase in purchasing power? I'm going to pause the video and you should give that an answer, and when you come back we'll see how our answers compare. So we're back, and hopefully our answers match up, but the year they had the worst purchasing power was in 2015. And you look at the graph over here. Even though they had a $5.15 minimum wage, their purchasing power, when they normalized the dollar back to 1996, was only $4.15. In 1970, they had the greatest purchasing power. And in terms of figuring out where you have the greatest increase in purchasing power, that would have happened in the years from 1955 to 1960, where their purchasing power increased by almost a full dollar. And if you did a percent change, you would have 91 cents purchasing power increase when you do the difference over $4.39. So that would be 0.91 over 4.39, and if you multiply that by 100, that would give you the percent increase, and that's clearly the largest percent increase. So the purpose of doing this was to show you that there's lots of things that we can draw out of a table of data, and there are lots of questions we can answer by analyzing data. And one of the objectives of this lesson is to be able to look at data numerically and make conclusions that are justified by the numbers. So moving on to our next example, we want to compare a piece of property that's rectangular with another piece of property that's circular. So in this case, we might do something that's more algebraic. So we'll call property 1, that will be rectangular in size, and that will be 100 by 50 feet. And then we have property 2, that's circular, and that would have a diameter of 80 foot or 80 feet. So which property is the bigger property? Now in this case, we don't have a data table, but we're going to use algebra to do this, or an equation. So set up the equation and compare the properties to see which one has the bigger area. Well, I've worked out both problems, and the rectangular area was pretty easy to figure, and so was the circular. But the only thing you have to remember is that the circular property it's a diameter that they gave us, so we have to make sense of that and make sure we're using the radius. And it turns out that I would consider this to be a tie, although the circular one is a little bit bigger. They're virtually the same size pieces of land. So, but again, in this case, we wouldn't use a numerical method. We would use an algebraic method to figure out our comparison. The last problem we have is for visualizing data, sometimes we have to resort to a graph. So as you know from physics, Galileo is one of the founders of observing physical bodies moving, and so there's some data that was taken, and this was taken through the use of inclined planes, and it shows here the elapsed time of balls rolling down inclined planes and how far they traveled. So when we look at data on a table, we want to try to characterize what type of data it is. Is it linear? Is it parabolic? Could it be another form of data? So a lot of times in doing this, it makes the best sense to make a graph and visually inspect the data. So what I'd like you to do is use Desmos on either your phone or on your computer and plot the data that is shown here, and then describe are the points forming a line or a parabola, and then we can understand the phenomenon better as far as what type of data this is. Okay, so I'm going to go to Desmos, and we're going to plot that data. Hopefully you've done this as well. So you just go to Desmos and you put into your equation, you just add a table, and we're just going to put our x, y values in. So the elapsed time, we're going to go from 0, and our first value, we're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to go over and put our y value in, and that would be 0 for the first point, 0.75 for the next point, 1 for the next, 3 for the next point. I took a picture of the screen and I'm reading it off of that, so that's how I'm not able to memorize all these points, but you can see how the data is forming. It's starting to form something nonlinear, so the fourth point is going to be 18.75, then 27, and let's just scroll out. You can see that it's forming more and more parabolic than definitely linear. So 27, I put that point in before, we got 36.75, and 40, I think I made a mistake. Let me look at the data. So I got 0, 0.75, 3, 6, this should be 6.75, then 12, then 18.75, then 27, 36.75, and 48. And as you look at the data, when it's all put in, it's definitely parabolic. It's not a linear fit of data. So anyway, back to the point of the lesson. In order to see what type of data we really had, it was imperative that we used a graphical approach to view the data. And hopefully, in working through this short video, you've seen 3 examples of how we study problems. We could study them numerically by analyzing the numbers in the data. We could study them algebraically, or we could study them graphically. We'll be doing more stuff with these types of problems in class, but this was just more or less a primer to get your minds working in the direction of not just doing everything algebraically, but doing things with numerically or graphically. Look forward to hearing your comments.